Hello everyone. So I hope you have seen all the previous videos on algorithm subject. Now we are continuing this lecture with the previous topic which we left. The previous topic was finding the time complexity of various functions. Okay. So we'll start with the same time complexity concept here, and then we'll take more examples here. And after taking all these examples, I hope the concept will be clear to you. Fine. So let us start now. Now let us discuss these three questions. The first question here is we are using a for loop and a while loop. Now let us try to find out the time complexities of these questions. Fine. So the first case, you will see every time whenever we are finding the time complexity, it does not matter that if a particular statement is going to take constant time. Okay. Now only the thing which creates a difference is how a function is growing as compared to the input. Fine. That means whenever we are going to pass some input to a function, then at what rate according to that input a function is growing, that is going to define what is the time complexity. Okay, what I am saying is, let us suppose if we have a function like this, if we are saying we have some function like this, fun int something n, then if we are doing printf %d comma n, and we are doing this for, let us suppose, 1 million times, or you say 10 million times, right? Now assume we have such kind of program. Now in this case, in this program, the number of statements which are being executed is just constant. The number of statements which are being executed, they are not dependent on the value of n. Every time whenever you are going to call this function, every time this function is going to print this value of n up to 10 million times, right? Then in that case, what you can do is we have a function fn for this, where every statement is going to take unit amount of time. Therefore all these statements are going to take approximately 10 million units of time, which is approximately equal to order of 1 only. Why? Because if we take a function gn, in that case of gn, we can assume that value of the constant c is 10 million or 10 million, some value which is greater than 10 million, right? So because this is just a constant value, so we are only going to the time complexity is only going to be affected if the function is going to grow on the basis of the input. Fine. Now in this case, this statement is a constant statement. In this case also, this statement is a constant time, it is going to take constant time, and this statement is also going to take constant time. These statements are not going to change according to the input. The only thing which is changing is the number of times this for loop or this while loop is executed, number of times this for loop and this while loop is executed, the number of times these three for loops are being executed. That means for all these cases, we have to identify how many times the for loops are being executed, or how many times what is the maximum number of time a statement is going to be executed. Okay. Now let us see the first case. Now in the first case, you can see this statement is going to be executed only once, right? So this is going to take 1 unit of time, right? This statement is going to be executed how many times? It will be dependent on this. It will be dependent on this, right? So we have to identify how many times these statements are being executed, or how many times the value of I is true, or you can say this equation is true, right? So let us identify for this case. What happens is, initially the value of I is n, right? The value of I is n. Fine. So n is greater than 1. Yes. Again we are going to execute this. Then we are going to make I is equal to I by 2. Therefore the next time the value of I will become n by 2. Fine. So n by 2 is greater than 1. Again we are going to execute this. So next time the value of I will become n by 2, which is equal to n by 2 square. Again n by 2 square is greater than 1. So we are going to execute this statement. Therefore how many times it will be executed? N by 2 cube, right? Up to so on. Let us suppose this is n by 2 raised to power k. Okay. Now when will this condition will become false? This condition will become false only when n by 2 raised to power k is going to be less than 1, right? That means if we say n is less than, if we say n is greater than equal to 2 raised to power k, till that time this statement executed, but when n becomes less than equal to 2 raised to power k, then this statement will be false. Why? Because if this 2 raised to power k is greater than n, then this n by any number which is greater than n, number is going to return you 0, right? So therefore it is going to give you 0. Now till this time how many times this program is this statement was true, or how many times this for loop has already ran. Okay, so that is dependent on this. You can write this is n by 2 raised to power 0, this can be written as n by 2 raised to power 1, this can be written as n by 2 raised to power 2, this can be written as n by 2 raised to power 3, and this can be written as n by 2 raised to power k. So when this 2 raised to power k is greater than or equal to n, then this condition will become false. Till this time, how many times this loop ran? This loop ran up to k times. Why? 0, 1, 2, 3, 4, 5, 6 up to so on k minus 1. Till 0 to k minus 1 this condition is true, but when this 2 raised to power k is there, then this condition will become false, right? So what I am saying is, we have to identify the value of k to tell you how many times this for loop is going to be executed. So to this you are going to use this. Now let us take log on both the sides. Therefore this statement will become log n is less than equal to log of 2 raised to power k. So you can write it as, let us suppose the base of the log is 2, therefore it can be written as log n base 2 should be less than equal to k into log 2 base 2. And what is log 2 base 2? It is 1. Therefore k should be less than equal to log n base 2, right? Therefore this for loop is going to be executed log n base 2 times. Fine. Now if you consider this while loop separately, what we can do is, either we can identify how many times these statements will be executed, or we can identify how many times, what is the maximum number of times this innermost statement is going to be executed. Okay, what I am saying is, if you have 2 loops, then you can identify here how many times this loop will execute, you can identify how many times this loop will execute, and according to this loop, because of this loop, how many times this loop will be executed, because the maximum number of times the statement which is being executed is this or this, right? So let us identify how many times this loop will be executed, right? Now for this case, the value of j is going to be started from n. So the first value of j is going to be n, right? Next time the value of j is going to be n by 2. Next time the value of j is going to be n by 2 square. Next time the value of j will become n by 2 cube, up to so on n by 2 raised to power k. When the value of j is n by 2 raised to power k, then this while loop will be false, this condition will be false, right? And therefore we are going to come out of this while loop. Now till this point of time, how many times this ran? This ran up to log n times again, right? Because these two statements, this statement and this statement, both are similar, right? Therefore this while loop is also going to run log n base 2 times. This for loop is also going to run log n base 2 times. Therefore what is the time complexity of this function? The time complexity of this function will be order of log n into log n, which is equal to order of log square n. That is going to be the time complexity of this function. Okay, now let us take the second example here. In this case, again this statement will be executed only once. Now this statement, we have to identify how many times this statement or how many times this for loop is going to be executed. Why? Because till the time this statement is true, this we are going to execute this for loop. When this statement will become false, then we will come out of this for loop. We just have to identify how many times a loop is going to be executed. Fine. Now in this case, you can see we have how we are incrementing the value. We are making I is equal to I multiplied by I. That means here we are taking I square. Now when we are taking I square here, let us see what will happen. Here initially the value of I will become 1. So initially the value of I is 1, right? Next time the value of I will become 1 into 1, which is also equal to 1, right? So next time the value of I is also going to be 1. Next time again the value of I is also going to 1. Next time the value of I is also going to 1 again, so on, right? That means this condition is always going to lead us the value 1. Therefore this loop will run infinitely. So whenever a loop is going to run infinitely, obviously your program will not stop, right? In that case you cannot find the time complexity because your program is not going to stop at any case. Fine, we have to identify, or we have to make these statements to be we have to make this for loop, or this, we have to make this program to stop at some point of time, right? So what we can do here is, let us suppose instead of this we have I plus plus somewhere here, right? So what is the benefit of doing I plus plus? Let us see. Okay, so here the value of I is 1 initially and 1 is less than n, therefore this loop will be executed. Next time the value of I will become 2 here, and if you go to this statement, this will make it 2 square, right? Therefore the value of I will become 2 square, and if we come to this condition, then this will become 2 square is less than equal to n. Fine. So next time again the value of I will become 3 and this statement will become 3 square. Next time the value of I will become 4 and this statement will become 4 square. Up to so on till some point of time. Let us suppose the value of I will become k. Therefore this statement will become k square. Now when this condition will be false, this condition will be false only when we can say that k square is greater than or equal to n. When k square is greater than or equal to n, then this condition will become false, right? So till that time, how many times the loop ran? The loop is going to run, k should be greater than or equal to root n. Therefore loop is going to run order of root n times the outer loop. The outer loop is going to run order of root n times, right? Now let us talk about the inner loop. In the inner loop you can see we have every time j starting from 1, and every time what is happening here is we are going to make j is equal to j divided by 3. That means if the initial value of j is n, then the next value of j will come n by 3, and the next value of j will come n by 3 square. Next time the value of j will come n by 3 cube. Next time the value of j will come n by 3 raised to power 4, up to so on n by 3 raised to power k. And again, when will this condition be false? When this 3 raised to power k is greater than n. That means if 3 raised to power k is greater than n, then this condition will become 0. This is going to give you 0. In that case, what will happen? In that case, we can say k should be greater than log n base 3. Therefore this loop is going to run log n base 3 times, right? Therefore how many times this loop is going to run? Because of the outer loop. Because of the outer loop, this loop is going to run root n into log n base 3 times, because every time the condition is true, therefore we are going to execute this. Next time the condition is true, we are going to execute this. Next time the condition is true, we are going to execute this. Therefore this function is going to take order of root n into log n time. It is root n into log n time. Fine. Now let us take the next example. This is a very simple example. The only thing which I have done is I have taken 3 loops instead of 2 loops, right? And it is a very simple example. I guess you can have already done this, right? So now let us see for the first loop. How many times the first loop is going to run? It is going to run order of n times. How many times the second loop is going to run? It is going to run order of n by 2 times, which is equal to again order of n times. You have already seen this, right? Then how many times this loop is going to run? This loop is going to run how many times? Order of n by 3 times, which is equal to order of n times again, right? Therefore because of these outer loops, how many times this inner loop is going to run? This inner loop is going to run, and this print statement is going to be executed up to so many times, n into n into n. This n is for this, this n is for this, this n is for this. Therefore it is going to take order of n cube time, right? Order of n cube time. Now you must have noticed one thing. In this case, when I am taking these constant numbers in power, then I am not going to execute, I am not going to ignore them. I am not ignoring this constant number when they are in power. But when we have the numbers like this, some constant numbers, let us say we have a constant number n by 2 or n by 3, we are going to ignore the constant numbers. Again here we have seen somewhere here also we have seen some constant values n by 3, n by 4, I guess. Take these examples only. Here we are making it n by 3, right? Again, see, in these examples, I guess this is the base value. We are going to write it as log n base 2. We are only going to write it as log n, right? Here we are going to get log n base 3. We are going to write it as only log n. And here we are going to get log n by 2. That is, we are only going to write them as order of n only. These numbers are going to grow this function, are not going to affect the growth of this function, right? So I think you are understanding what I am saying is, these functions are not going to affect the growth in that, in a way this value is going to affect, right? These are not going to affect the curve of the growth. This is going to affect the curve of the growth, right? So that is why we will not ignore the growth when they are in the powers, right? Or the constant when they are in the powers. Fine. Let me take more examples and let me continue with it, okay?